Bicycloalkanes. An alkane that contains two rings that share two carbon atoms is classified as a bicycloalkane. The shared carbon atoms are called as bridgehead carbons, and the carbon that's connecting between them are called as bridges. The general formula for bicycloalkanes is CnH2n-2. Now here are some examples for bicycloalkanes for which the IUPAC name and the common name has been given. Now let's see how to get the IUPAC name for these compounds. Let's take a look into the first compound. This is a bicycloalkane, and the total number of carbons that's present in this is 9, and therefore the parent name is nonane. You have to put the prefix bicyclo in the front because this is a fused two-ring structure. Now the numbers in the square brackets is going to designate the total number of atoms leaving behind the bridgehead carbons, for which you're going to find the unique path between the two bridgehead carbons. So you can go in this direction. So in which way? There are 1, 2, 3, 4 carbons. So this number is going to represent that there are 4 carbons in between these two bridgehead carbons in this direction. And then when you go on the other side, you have a total of 3 atoms. Here are your 3 atoms, and this 3 is going to represent these 3 atoms. And then when you go in this direction, you can see that there is no carbons in between, right? So therefore this is going to be 0. So always make sure that you list the numbers in decreasing order. Let's do one more example here. The total number of carbons here is 7, and therefore the parent name should be heptane, and there are 2 cyclic ring structures which are fused together, and therefore the prefix of bicyclo. And how did we get the numbers 2 to 1? So take this one ring. So here are bridged carbons. Okay, you're going to start from one bridge carbon and then reach the next bridge carbons. By doing so, you are going to go through 2 carbons, and that's the number. And similarly, on the other side, you're going to go through 2 carbons to reach from one bridgehead carbon to another, and therefore this is number 2. And then the last pathway is from here to here, where you can see that there is 1 carbon, and therefore you have the number 2.2.1.